Okay, good morning once again. We said that multiple linear regression attempts to describe or predict your outcome variable or response variable or dependent variable. So there are many names for your dependent variables using the various independent variables or your predictor variables. Okay, and for our example, we were regressing hourly wage on education, experience, tenure, race, gender, civil status, and number of dependents. Of this, uh, race, gender, and civil status are categorical variables, and we use them as factors. Now, we learned that in R, perhaps because of the newer model of R, newer version of R, we need not convert these to factors. But nevertheless, we converted race, gender to and civil status to factors because the uh, earlier versions of R will return an error term if we did not convert them to factors. Okay, so just be aware of that. In case you were regressing a, a dependent variable on several types of independent variables, and if it returns an error terms and it gives a message that some of the variables are characters, then you have to convert it into a factor. Okay. Necessarily, our dependent variables should be continuous. We cannot regress this using LM, okay, using the LM function, if this was a binary variable or if this was a categorical variable. So the dependent variable must be continuous. And R will give us the result of the output. And here you can see that the intercept, education, tenure, and the categorical variable gender, they are all significant at 0.001. Experience is significant at 0.10 or 10%. Okay, so we learned how to set up the model. We learned how to interpret all the meanings of these estimates and pay particular attention to the intercept because there are categorical variables or factors or dummy variables, then you have to know how to interpret the intercept. But as mentioned before, we don't put so much practical implication on the intercept because it can generate results that are should we say yes, impractical. Okay, and we said that we do not stop there. We have to do stepwise regression and eliminate those one by one, those variables that are not significant, and we use the t-value, okay, the absolute value, the lowest value of t-value, considering only the absolute value as our leaving leaving, the variable that we're going to remove. Okay, and fast forward. So last time we were already in model number 5. Okay, so quick review. This was our model number 5, where 1, 2, 3, 4. Okay, am I still on, guys? Can you hear me?
Yes, sir.
Okay, sorry, medyo, I think disconnect ako eh. But are we still recording? Let me check.
Yes po, it's still recording.
Okay, thank you. Right, mic shut down. Yeah. Okay, thank you. Okay, so going back here, we use the LM function. So this is the regular.
Sir,
Yes.
nawala po yung share screen.
Nawala. Okay, thank you. Nawala yung share screen. Okay. Okay, can you see it now? Yeah, okay. All right. So we use the regular regression function in R, the LM function, linear model. Okay, and then we can print the output using the summary function, and this is what we arrived at. Okay, now notice all the predictors respond the independent variables are all significant. Okay, so you have education, tenure, gender, male, they're significant at 0.001 here. This one, 3 stars. Okay, and the other one, civil status, significant at 0.05. Okay, all right, then quickly, how do we interpret this? Okay, we said that to interpret this, we look at the estimate, the parameter, and this means that for every 1 year increase in education, there's a corresponding $0.529 increase in hourly wage ceteris paribus. Okay, for tenure, for every 1 year increase in tenure, I'm using year because tenure, the dimension of tenure is in years. For every 1 year increase in tenure, there's a corresponding $0.15 increase in hourly wage ceteris paribus. The ceteris paribus there indicate that only tenure will be increased by 1 year. The others will remain the same. They will not be increased. Okay. And then what does this mean? Gender male. On the average, male counterparts, male employees receive $1.71 more than their female counterparts, ceteris paribus. Okay, and this one, civil status, it means that on the average, single people receive $0.68 less than their married counterparts, ceteris paribus. Okay, so the factors, the character variables which have been dummified, but we dummified this, which means we represented them by 1 or 0, and R automatically did that for us. Okay, because it's Excel, if you're going to use Excel, regression in Excel, you will have still to convert them into zeros or ones. And then just a reminder, what did we learn, class? If a variable, an independent variable is a character variable, and you can use it to classify, okay, how many dummy variables are we going to introduce? Anyone? Suppose we have a variable, let's say year level. Okay, so you have frosh, sophomore, junior, senior, and then graduating. So we have 5 levels. How many dummy variables will be introduced to your model? Answer, please. Hello? What's the answer? Paki-chat, please. Let me repeat the question. So this is our data. Okay, let me annotate it. Just to make sure that you understood this. Okay, so you have, for example, year level. Okay, only an example. Okay, and then this one is, let's say, frosh, and then frosh. Is sophomore, then another sophomore, junior, senior, and then a graduating, etc. So there are 5 different types, 5 types of year level. Now, since these are character variables and these are categorical variables, we can use them to distinguish between the hourly wage of the frosh, of the sophomore, etc. How many dummy variables should we be introducing here? Okay, Sophia, kindly share your answer to the class, please.
4 po.
Yes, correct. Why 4? What's the rule?
Number of levels po minus 1.
Correct. Thank you. Thank you, Sophia. That's correct. So the number of levels minus 1. So which means what will R do? So it will take a look at the alphabetically what appears first. So it's frosh, letter F. So it will introduce 4 dummy variables. So we have here sophomore, and then junior, and then senior, SE, let's call it SE, and then graduating. Okay, so there will be 4 dummy variables. So 4 additional columns for this. So for example, the first respondent is frosh. So there will be 0, 0, 0, 0. Okay, that will be frosh, right? The next one is frosh again, so same, 0, 0, 0, 0. And then the next one is sophomore. So it will be for S, sophomore 1, 0, 0, 0. Okay, so all the variables will be captured with this, with the 4 dummy variables. Okay, everything will be captured, including the frosh, although we did not include the frosh here. Now, what will happen if we included frosh? Let's say we included another one here. So you'll have 0, 0, 0, 1. Okay, now what will happen is what we call a dummy variable trap. Dummy variable trap. We will have what we call perfect collinearity. Okay, and that will violate the assumptions of our linear regression. Okay, so as we go on, guys, we'll understand more this what we call dummy variable trap, resulting into what we call perfect collinearity. Okay, but what if I want to include? Okay, what if I really want to include frosh? Can it be done? Yes. If you want to include frosh as a dummy variable, then you have to remove the intercept. Okay, we have to remove intercept from the model. So hindi natin isasama si intercept sa model if you want to choose the five categorical variables. So as to my question, is it possible to include all the 5 levels of your categorical variable? Yes. Okay, but you should not include intercept as a predictor. Okay, and that's possible. Okay, and how do we do it? How do we exclude intercept? I'll show you in a while, guys. So let me pause for a while. Kindly chat, please, if that explanation was clear. Is it clear so far, guys? Dummy variables. Okay. So don't forget that, class. Automatically, R will do that for us. If we introduce, if we include dummy variables in our equation. Thank you. Thank you. In fact, isn't it, class, that in model 1, so let's go back here. In model 1, let me go back to model 1. Okay, here. This was model 1. You notice that automatically it was R that introduced the dummy variable. And the race variable has only 2 levels, white and non-white. And automatically R did that for us. Okay, it set the benchmark non-white as the benchmark because it appears alphabetically first. So when we interpret this should be interpreted with reference to our benchmark. So for our first model, if you recall, we were saying that white people receive $0.1, $0.11 more than their non-white counterparts, ceteris paribus. However, it was not significant. But Nevertheless, if this was significant, we would have interpreted race that way. Okay, thank you. Thank you for the feedback. All right, so let's go to model number 5. Let's finish this. Model number 5. Okay, and what we do, we compare, right? We compare model number 4 and model number 5. Model number 4 was the one with model number 4 had, let's see, education, experience, tenure, gender, and civil status. 5 predictors. And from model number 4, we okay, sorry. This is now model number 4. We eliminated experience, no? In model number 4. That's why in model number 5, there was no experience anymore. So how do we determine if model number 5 is better than model number 4? Okay, there are different ways to do that. One is by comparing the Akaiki, no? AIC. And we said, based on Akaiki, the lower the information loss, the better. Okay, here it turns out that model number 4 is better than model number 5 by virtue of having the lower AIC. Okay, but if we're going to test it statistically using ANOVA, the analysis of variance, and if you recall, the null hypothesis here is that, let me just write that, HO, the restricted model, okay, which is, what's the restricted model here? Model number 5. It has the less number of predictors. The restricted model is better than the unrestricted, which is model number 4. Okay, what's the basis of restricted? The restricted model is the one with the less number of predictors. Okay, that's why it's called restricted. The unrestricted is the one with more. So comparing number 4 and number 5, model number 4 has 5 predictors. Model number 4 has 5 predictors, yeah, and model number 5 has only 4 predictors. Okay, so based on the analysis of variance, okay, so we have the p-value at 0.11, which is greater than 0.05. Therefore, our inference is that we fail to reject the null hypothesis that the restricted model, which is model number 5, is better. Okay, so model number 5 stays. And since all the predictors in model number 5 are significant already, then that will be our final model. Okay, so we use what we call stepwise regression in coming up with the final model. Okay, now how did we do stepwise regression here? How did we do stepwise regression? What we did was to manually go through the process of looking at the insignificant predictors and then eliminating the one that had the lowest t-value. Now there's a package in R that can automatically do this for us. Okay, and this package is the olsrr package. So let's first make sure that loaded yung control alt I library. Oops. Okay, let's just make sure that loaded in library. Okay, let's require the olsrr package. Okay, and before we continue, let's go here, packages. And let's see the help function. olsrr here. We click this. Okay, tools for building OLS regression models. Okay, so here is a description file. olsrr package. The latest version is 0.5.3. Okay, these are the authors, Aravind and Hebali. Looks like Jewish sila. It's a tool that's designed to make it easier for users, particularly beginner intermediate R users, to build OLS. No? Includes comprehensive regression output. Okay, these are now the diagnostic test, heteroscedasticity test, collinearity diagnostics, residual diagnostics, measures of influence, model fit. Okay, so a lot of things that we can use with the olsrr package. Okay, so I would that you go over this. Okay, kunyari user guides, may vignettes pa. Let's take a look at the user guides. Okay, for example, heteroscedasticity, influence measures, may intro pa dito, regression diagnostics. Okay, for example, OLS regression diagnostics, because this will be the next lesson. We don't stop at merely being able to generate the final model. We have to look at regression diagnostics, residual diagnostics, and variable selection. And you can find it here. The R code is even listed. So let's see, for example, let's start with heteroscedasticity. Tingnan natin yung R code na yan. Okay, and then it will give us several examples. Ito. What's good about the tutorial in R is that it also gives us some examples by which we can work on. For example, this one, these are the packages used. And then okay, here it created a model, LM. This is coming from the data empty cars, which comes preloaded with R. Okay, and then OLS test, Bruce Pagan test. Okay, all right. I will not show this now, but I would encourage you to look at this. So what does the Bruce Pagan test do? Anong ginagawa niya? No? What does it test? Kasi meron ditong Bruce Pagan and then several types of Bruce Pagan. Okay, hello, can you hear me?
Yes, sir.
Sorry, I think I'm getting disconnected. All right, so as I was saying, this is a test for the residuals. In particular, yung homoscedasticity and heteroscedasticity, I mean, kung yung residuals natin are heteroscedastic. So we can make use of the Bruce Pagan test, and it's all found in your OLS package. Aside from that, guys, meron pa tayong regression diagnostics. So let's take a look. Let's take a look this time at an HTML. So pag in HTML natin, makikita natin yung printout. So these are the regression diagnostics. Meron tayong collinearity diagnostics. May tolerance, pareho pa lang yan. Okay. Meron tayong model fit assessment dito. Okay. All right. So meron tayong variable contributions. So a lot of things, class, that we can generate from OLSRR, and not to mention other packages. But OLSRR for regression diagnostics, it has really a lot to offer. because in your exams, guys, you will have to not only generate the model, you will also have to diagnose it. So aside from regression diagnostics, meron tayong residual diagnostics. So let's go this time to source. Okay. So ito yan, ano? This is your regression diagnostics. So what's good about this is that it tells us kung ano yung dinadiagnose niya. This tells us for test for detecting violation of normality assumption. Diba? Ito yung number 6 assumption natin. Residuals should be normally distributed. So how do we test for that? Okay. So you can have here some, and then what's good is that may example na dito. No? Tapos may konting explanation. Konti lang explanation. The others, you will have to search for it in other sources. Okay, so that in a nutshell are there's so many functionalities that we can derive from olsrr. In fact, dito yung ano niya, no? Andito yung mga functions niya. For example, ito may test data set na kasama siya. Auto, cement, fitness, HSB. I think this is from SPSS, I think. Okay, and then here are the other functions. So lahat nagsisimula sa OLS. Ito naman plot.ols. Okay, so it will benefit you to look at the functionalities of the olsrr package. Okay, in the meantime, let's go here and okay. Let's first take a look at forward regression. What do you mean by forward regression? Because what we did was backward regression. So when we say forward regression, you start with a no model. Okay, no model means you just use the mean of hourly wage as the as the predictor. Okay, you're not using any independent variable or any predictor variable to explain hourly wage, and then you add one by one. Okay, so that's what we mean by forward regression. What we used before was backward regression, when we loaded all the variables, the predictor variables, and then one by one removed, eliminated until we came up with the final model. Okay, so let's use AIC here in this instance. Okay, so take a look at our code. So we're creating this model, and then here's the usual LM function, wage regressed on education plus experience plus okay. Okay, wait lang class, ha? What did I do here? Okay. Here it's using wage interact. Apologies, class. So let's change this. Kasi I think I used this in another class and we were using this. Check muna natin, class. So there's a data called wage interact. Does this come with R? Not found. Okay, so we will have to change this. So this one we change to gender. Okay, nag-interaction ako dito. No? Dali lang, ha? Wala ang data set, no? Sorry about that, guys. Okay, wala. I'm looking for if there's a none. So none. So I think this is a modified data set. All right. So let's change this. I'm sorry about that. Let's just copy the model one now. Let's copy model one. A model, yeah, model two pala, sorry. Model two. Okay, this one. The whole 7. Go back here. Forward regression. Okay. Wait. Where's that? Here. The values pala muna natin. Sorry about that. So, okay, what was I pointing to a while ago? What was I seeing? Okay, but let's start here first. I jumped, sorry. All right, stepwise regression method 1.1. Okay, we required olsrr. Okay, and then here we're creating this object called model. So model is the linear model for hourly wage regressed on all our predictor variables. Okay, and if you recall, we can actually replace this by dot. No? Pag sinabing dot class, it means we're including all the predictor variables and data is equal to age. Okay, so here, take a look at this. We're creating this object forward fit.p. Okay, because we're first using p values as a basis for the entry of a variable. And the function is ols step forward. Okay, so this is coming from your olsrr. So ols underscore step underscore forward underscore p. Okay, and then we're linking it to our model. This is our model, our linear model. Okay, and then p enter. So this is the basis. Okay, this is your significance level, 0.05. Okay, which means that a variable will only become part of the model if its a p-value is less than 0.05. If it will generate a p-value less than 0.05. Okay, so let's run this now. Okay, so we now have running. Okay, so we now have that object, forward fit.p. Let's first take a look at this. Okay, so it's like a regression model where yan, andito yung mga mga outputs predictors. You have this mallow CP, okay, AIC, SBC, and the model itself. Okay, so it's a list of the different outputs. So let's print this output. Okay, here. Okay, let's print the object forward fit.p. Okay, this is what I mentioned a while ago. Page regression all. Okay, on all. All right, so let's print this. And it gives us a long summary lang yan, ano? Summary lang siya. Okay, let's take a look at the summary first. Okay, so this is the first step. First step, variable entered education. Okay, education, no? R squared is 16%. Adjusted R squared is 16% also. Then this is Malo CP, which we're going to discuss some other time. And then AIC 2777.423. Okay, and root mean square error. So this is a measure of the residuals. Okay, so the next one is tenure. We're going to introduce now tenure. Include tenure as part of our regressors. And you can see that R squared went up, no? 30% tumaas. Tapos si AIC bumaba, 2685. Okay, next entering variable. Take note, this is forward regression, no? Forward stepwise regression. So in this case, the variables are being introduced one at a time, but the p-values are all less than 0.05. So si gender naman, notice that as we add more variables, the R squared increases. No? Here also the adjusted R squared increased. Okay, and then Akaiki is lower, 2643, and then finally civil status was entered. Okay, with adjusted R squared 36%. Okay, and CP's Malo's CP okay, lower 6.2. Akaiki lower 26.39. So this is the summary of the variables that were introduced one by one using forward. Okay, forward regression. Yan. Using p-values. If you want a more complete, tingnan natin kung ginawa ko dito yun. Okay. If you want to a more complete so this one, okay, summary, forward fit that p. Okay, so let's summarize. Okay, just like in any regression output, let's summarize this, and it will, oops. Wait, hindi. So let me see. What's the command? It should give us the. Okay, so wait a minute. The summary function just gives us the list. So let's see. What's the command for that? Is it print? I want all the results to be Okay, it still doesn't give, because it's supposed to give us the one step at a time. Okay. Okay. Anyway, let's continue with this. Hopefully later on ma-recall ko kung ano yung function to print all the steps, not all the steps. Okay, so this is because this is already the summary. Okay, and let me see. Model. Let me try one more time. Forward dollar. This just gives us the final answer. No? Coefficient, education. Okay, so all right. So let's just proceed first. But what's important here is that, okay, this is the final model using forward regression, forward stepwise regression, and the variables are introduced one at a time. So first, education, and then added next is tenure, added next is gender, added next is civil status. Now it did not anymore add another one because that other one, when you do regression, had a p-value greater than 0.05. So only these four and the p-values of these four variables taken together when they were regressed all at the same time, education, tenure, gender, civil status, they were all less than 0.05. Okay, so let me pause for a while, class. I think I might be going too fast. Kindly chat, please, if so far the discussion of forward stepwise regression using olsrr, using in particular p-value, is clear. Kindly chat, please, guys. Thank you. Good. Okay. Although I haven't seen the others give their feedback. Okay, so that's what the forward stepwise regression does. Forward stepwise regression using p-value. Okay, thank you. Okay, we can also use forward stepwise regression, but using AIC as the basis, which means, okay, may question lang. Sid, kindly share your question to. Okay. Sid, we'll discuss yung both. Okay, iba yung both, no? Nasa baba yan. So medyo na-advance ka, but that's good. No? So yung both kasi, titingnan both forward at backward. Okay, so Sid is saying here that she used OLS step both P. Okay, there's this function. No? What we used a while ago was, ito lang ginamit natin. This one. OLS step forward P. Okay, and then Sid indicated that she used OLS step both. So both indicates you're using forward and backward. But let's discuss that later. Thank you, Sid, for your comments. So now let's let's still do forward, but this time we will use AIC as the basis. Okay? So same pa rin yung ano natin, same model. In fact, this was not needed anymore because we already defined what model is. No? So here we're creating an object called forward fit, and then the function is OLS step forward, no? AIC. Okay, so this is the function, and then we're going to do that in model. Notice dito, no p enter here. Okay, we did not put p enter because we're not using the p value as the basis. Okay, so we're using here AIC, and sa AIC it makes sure that the AIC is the lowest. No? Okay, so let's just run this. Okay, and then here, short summary. Okay, so what happened here? Now take note. The variables that will be used for the model is 5. No? So education, tenure, gender, civil status included is experience. So education, tenure, gender, civil status, it's the same for the forward regression, but using p-value. Okay. Now it did not include experience here because experience, as we have seen, it's not statistically significant. But here it's included because the basis is not p-valued, but the basis is the lower AIC, this one. So note that when we included experience, AIC went down. AIC went down. Okay. However, you can see that the sum of the squared residuals went up. And R squared here, adjusted R squared went up. Obviously, it will go up because you're adding more variables. The adjusted R squared, the R squared will always be higher if you have an additional variable. So here you can see the conflict between the we're having two different models, one with 5 predictors, the other one with only 4 predictors. One uses the p-value approach. It did not include experience because experience turned out to be, it was significant, but at 10%. Okay. However, that model with 5 predictors, actually model 4 yan in our case, when we did the manual. Okay, but it has a lower AIC. Okay, and recall that AIC can also be used as a benchmark or as a tool to determine which model to adopt or to follow. Okay, and in here we learned that there can be a conflict between AIC and also the p-value. For our purposes, we're going to use the p-value because we're going to really peg the level of significance alpha at 0.05. Okay, to make things simpler for us. All right. So I just wanted to illustrate here that there might be a difference in the model if we're using AIC vis-a-vis as compared to the p-value. Okay, so let's plot FW fit.aic and let's see. Okay, it gives us a plot of the variables that enters here. Okay, it's a plot of the value of the AIC and the entering variable. Okay, here education, you can see here, This is the value of the AIC. When you introduce tenure, your AIC went down. When you introduce gender, your AIC went down. When you introduce civil status, it went down. And finally, experience. So these are the 5 predictors when you're using AIC as your basis. If you add another one, your AIC will go up. Okay, so this is what the plot function for forward fit AIC, the object that we created, gives us. Okay, so pause for a while, guys. Clear so far? Kindly chat, please. If so far, up to this point, the plot that we did for the forward stepwise regression using AIC. Okay, thank you. Good. Okay, so let's ito, ayun. Ito yung nakalimutan ko. Okay. So if you want the intermediate steps, we have to add this. Add details is equal to true. All right. So here, we're going to use the same name, forward fit, that AIC, and then OLS, step forward AIC, model, and then we have to define, we have to include these details is equal to true. So this is what I was trying to recall a while ago. Okay, so this is it, no? We include details is equal to true. If we run this, okay, let's see. Okay, it's quite a long output. It gives us the steps that were undertaken in order to generate the final output. Mahaba. Okay. Can you see this, class?
Yes, sir.
Okay. So medyo maliit, ano? Dito na lang. I'll just use this one. All right. So this is the forward selection method, no? Okay, these are the candidates. These are the 7 variables. Step 0, okay, hourly wage regressed on 1. What does this mean? Okay, so this means, class, that if we're going to just use one variable of the 7, okay, if we're going to use education, this is the AIC to be generated. If we're going to use tenure as a predictor, this is the AIC. If we're going to use race, this is the AIC. Okay, and it turns out that the education, if we're only going to use one regressor, education has the lowest AIC. So this is now your entering variable, education. Okay, so initially, class, if we're not using any variable as a predictor, okay, in other words, yung average lang ni hourly wage ang gagamitin natin, we're not going to use any of the variables, then your AIC will be 828.70. But if we introduce education, okay, the AIC will become 2777. And if we introduce race, the AIC became 2871. So it even increased. AIC even increased if we're just going to use race as compared to no predictor variables. Okay, remember step 0, this is the regression where you're only using the average of hourly wage to predict hourly wage. So no matter what the situation is, no matter if there's experience, education, etc., it doesn't matter. We still use the average of hourly wage as a predictor. And the AIC is 2870. But if you introduce education, AIC will go down. If you introduce race, ALC will even go up. So it doesn't make sense to use race as your predictor. Okay. So after that step, yeah, we add education. Okay. And with education now, AIC is now 2777.42. Okay, so it's now hourly wage regressed on education. Okay, here, hourly wage regressed on 1. So this means hourly wage regressed on the intercept or the average. Okay, so ngayon, our model is now hourly wage regressed on education. And if we introduce another one, okay, here, tenure. You introduce another one, tenure, AIC becomes lower, 26. Okay, and if you compare them, what's the best to include as an entering variable? It is tenure, because AIC will become the lowest. Unlike if you introduce gender or if you introduce experience with education, the lowest AIC we get is tenure. So that will now be our model number 2. We add tenure here. So step 2, AIC now became 2685.10. And this is now our model. So you see here, class, it's a stepwise regression forward. No? We're introducing one variable at a time. Okay, and then gender, civil status. So for step 3, we introduce gender, so plus gender. AIC became 2643, lower than the previous one. Okay, so we added gender now. So our AIC now is 2643. Notice that we keep on lowering AIC. Okay, and we now have 3 predictors. Okay, and then next step, let's see. Will adding any one of the remaining variables lower AIC? Yes. Okay, if we add civil status from 2643, AIC becomes 2639. Okay, so what happened? By introducing civil status, we now have this equation, right? And our AIC has now been reduced to 2639. And finally, adding experience, okay, will still lower the AIC 2638 from 2639. So step 5, we added experience and our AIC became 2638. Then if we take a look at the remaining 2 variables, adding number of dependents will not lower AIC. In fact, it will increase. So from 2638.6, it will become 26.08, 2638.8. So this is rejected, and all the more raised. All right, so that will be our final model. Okay, no more variables to be added. Variables entered: education first, plus tenure, plus gender, plus civil status, plus experience, and we have here the final model output. There. Adjusted R squared is 36%. Then we have the root mean square error, coefficient of variation, mean square error, mean absolute deviation, mean absolute error. Okay, kindly try to see what this measures. These are different measures of error squared. Root mean square is just the square root of MSE. And you know this, guys. How do you get the mean square error? You get the difference between the actual value and the predicted value. Okay, you square it, and then just get the average of that. For this one, root mean square error, you not only get the average of the squared error terms, you also get the square root of that. Okay, so that's why just checking square root of 8.7, Control C, Control D, you get 2.9095. Okay, so that's your root mean square error. So these are all measures of residuals. Okay, and of course we would like the residuals to be lowest. All right, then this is our final model, the ANOVA. Okay, overall goodness of fit, to recall this. And then the parameter estimates, these are their values. Okay, and take note, guys, take a look at this. Okay, experience is not statistically significant. In fact, civil status is barely statistically significant. Okay, but since we're using AIC as the basis, then we're still going to include this because this will generate the lower AIC. Okay, now I leave you guys to, as an exercise, to also do this for the first model. Diba? Yung unang ginawa natin. Ito yung details is equal to true na to. Okay, gawin nyo to dun sa una. Yung F forward fit dot P. No? The unang model natin. OLS step forward P, then model, then details is equal to true. Okay, and try to see, ganun din, it will give us stepwise regression. It will include one by one the variable to be included based on p-value. Okay, now we can also use this backward regression. Okay, so palitan natin tong, sorry, iba yung data na nagamit ko. Okay, so let's, okay, hindi na natin kailangan pala ito. Alright, so let me just delete this. Okay, kasi na-define na natin si model, di ba? Okay, so this time, let's call it backward dwd fit.p. Ito naman, no, OLS step. Kanina, forward to. Forward dash p. Ngayon, backward underscore p. And then, model. And then kanina, p enter, 0.05. Ito naman, p remaining. Okay? So, what p value do we allow a variable to remain? Okay, kasi backward to. So, let's print this. All right. So this just gives us the summary. Okay. Dito, tatlo. No? Tatlo lang. Bakit tatlo lang? Kasi model 5 natin, 5 eh. Let me back to it. Model 5 natin, 5. So this is... Okay, may kulang ba ako? Okay, 5. This is significant at... Yeah, at significant naman to. No? Significant at 0.05. So okay siya. Pero dito, why am I getting only... sorry. My bad, guys. My bad. Ito, okay. Ito, yung eliminate, no? Okay. This was what was eliminated. So first, in-eliminate yung race, tapos in-eliminate yung number of dependents, tapos experience. Okay. So it's already time. Guys, kindly, pakiran na lang to, no? Yung my details. So let me just copy that. Yung my details sa taas. And then please study the movement, no? C. Copy ko lang to sa baba. Control V. Tapos to backward, no? Backward dot P yung ginamit natin. Using P values. Tama ba? Backward fit dot P. And then this one, this should be backward na. Backward underscore P. All right. Then isama yung details is equal to true. All right. Kindly, if I run this, guys, again, papakita yung ano, no, yung details, no. So I'm sure, guys, you'll be able to understand this. Ang kaibahan nito, okay, ang pinapakita dito yung tatanggalin. kaya minus, no? What will be removed from the model? Okay, so let me stop there. Stop.